Welcome to our today's video tutorial about the Kathrein app TagBlower. My name is Michael Kaiser, Director Product Management at Kathrein Solutions, and I will show you in the next 15 minutes all the benefits of the Kathrein TagBlower app. Maybe you have already seen the latest video tutorial from us about the administration of the TagBlower with the app manager, with the details how to handle the keys and how to do so. If not, please have a look here. You will find you will find a video showing how to administrate the Reader Start software and the TagBlower app. Today we will focus on the application of the TagBlower. This means the small app is running directly on a reader. In our case, in our example, it's the RU1400, but you can use any other Kathrein reader. We have here an IP address, and the Reader Start software is connected to the TagBlower to parameterize the reader and to test the application. If a tag arrives at the antenna, it will be collected and immediately transmitted to the client connected. In our case, the Reader Start software, and you see the tag is arriving and the EPC is showing as coming in event. When the tag is leaving, you get another message as a going message with the same EPC. You can connect up to 4 standard antennas and up to 32 cry antennas. The cry antennas are special antennas from Kathrein, which we can cascade, for example, in a shelf application. Have a look to the smart shelf cry antennas if you're interested in. On the other side, we can connect unlimited numbers of clients to connect directly on the TagBlower server to subscribe the information, the data from this TagBlower app. Here in a written format, the details about this, the asynchronous commands, this means the app is running in the background permanently, but only if an event arrives, so a tag is coming, a tag is going, we will generate a message. And you can build up with so-called datagrams how these messages look like. Here is the administration page of the TagBlower app on the app manager. You will see the information about the keys and the handling. And here is a reminder, if you have an interest, how to address the keys, how to get the keys, how to set the keys, please have a look to this video. The use port 14007 is the TCP protocol port, which is used in this case. It's a handshake. This means if a handshake is valid, is running, then we can transmit the data in a bidirectional way. The details about the magic words you find here on the next page. And by the way, you can also get a manual from us. Meanwhile, the version 1.04, where you can find all these magic words, all these sums in detail. Have a look there. You will find more information about the magic words, but the basic things I will show you in this presentation. Okay. EPC is the first memory bank you will read out from the transponder to get the information. And these are the things we can show. And how does it look like? Sorry, wrong page. The magic word is EPC, and the parameter we can change or can influence is the coding. In real life app, the EPC is transmitted with a respective transponder. This means we have here the data on the tag, the EPC data. In our case, is always zeros and ones. In our case, we are interpreting this as an hex data. This means the 0011 represent the 3, the 0001 is the 1, and so on. So in our case, and coding 1 is default, is the hex coding. But you can also code as ASCII. In this case, this 31 stands for the 1, this 52 stands for the R, this 46 stands for the F. It's also a possibility to code. The stored data is the same, but the way to translate or to transmit looks different. And finally, a coding number 2 is also available. This is a 6-bit coding, which is popular for the vehicle manufacturer, for the German VDA. standard VDA 5500. There is a ISO 7367 available. This is a 6 coding. Have a look at this link I have connected to you. You can see the details. And in this case, the same string of 0 and 1s will be transmitted as LUI and so on. In addition, you can also handle other data. This means you can have access to other memory banks. Maybe you know that we have up to 4 memory banks with the transponders where we can address. We have the EPC, which we have already shown. We have the TID, which is a transponder ID, a unique number. We have the user memory, and we have a memory bank called RFU, reserved for future use. All these 4 memory banks you can address. We have a pointer. This means from which starting point we start the reading, and we have a length, how many bytes, how many data we read. You can set passwords to get access for a scrambled memory bank. We have the possibility to retransmit errors. If you have an access and, for example, the password is incorrect, you get a reply on this and you can see this. And again, here we have also the possibility to set the coding. In our case, we have this example with a TID, the transponder ID memory bank. This is memory bank number 2. We read from the beginning and we read a length of 8 bytes. So in our case, we have this information here, and you see we have 1110, and these are corresponding for hex data with the E. If you have no experience with this, please have a look. Take your calculator, and when you select binary, and we have the 1110, and select hex, you see this is a capital E. So this is a way how you code the data. The data on the transponder is fixed, but you can code it on the way you need for your application. And finally, here is the counting that you see. We have 8 bytes in a row. Additional information can also collected. This is the antenna port, from which antenna I have read this data. The antenna property, in case of we have this cry antennas, this connected smart shelf antennas, that you have the information, what have you read and on which position, on which antenna you have read this. We have the RSSI information. This is a received signal strength indicator. This means how strong is my signal. And we have, of course, a timestamp to know when it's happened. And I have prepared a little live demo to show how does it look like. We have here the reader start software. Again, here the administration path page, and when you go to configuration, we see here the magic word, and in our case, we have the following datagrams. For the common message, we read out the EPC coded as 0, this means as ASCII, is coming on port, and then we have the antenna port. The TID will be read out. The memory bank 2 is the TID. The pointer starts from the beginning with 8 bytes. And encoding is for example, hex. And then we have a timestamp. For the going message, when the tag is leaving, we have the EPC again coded as ASCII on port number and the timestamp. So we see the time when the transponder stays in front of the antenna. When the app is starting, the TagBlower app is starting, we send out a telegram called Hello World, in this case, to show the client now it's starting, now it's beginning. And we send out a heartbeat. This is necessary because, as I said, this is asynchronous readings. This means the app is running in the background, and if nothing happens, you don't see anything. That you see the system is still alive and is running, we can send up a heartbeat. This heartbeat will be set here with expert settings 2. We have here a parameter called hostcom, and when you open this, you see here heartbeat interval. In our case, we have set it to 5,000 milliseconds. In real life, you will set it maybe to 1 minute or longer to get a reply every minute and know exactly everything is fine, everything is running. Heartbeat. And finally, we have also a stop message. This means when the system is stopped, when the server is stopped, you get sent out an information to the clients that the session is now stopped. To show you this in real life, we have here also built in a listener in the Reader Start software. And I have connected the system as described here. And when I start the application, you see immediately hello world, everything is fine, everything is running. And you see also after 5 seconds, the heartbeat is arriving. So you see system is running also if nothing happened. When our tag is in front of the antenna, we get the message about the tag, the EPC, coded in ASCII on port number 1. We see the TID coded in hex, and we see this timestamp. By the way, this is UTC time. And when the tag is leaving, immediately we get the information. Tag is now leaving on port number 1, again coded as ASCII, and the timestamp. Okay. This was for the demo, for the test, but in real life, you want to have a system running to collect the data. In our case, we make the example now with the Kathrein Reader RU5000, 4500, where we can get access to the Linux and can use it as a listener. This means the listener runs now directly in the Kathrein Reader. We can connect to this reader with the TagBlower, with the 1400, and it could be any other client also. You see, we have with the 1400 the IP address 0226, and with the listener reader, we have the 055. And again, we will start this, and for this, I have connected a pretty connection. I type here in 192.168.0.55. Then I'm addressing the Linux on my reader. I will ask for a login as a root. And I will be asked for a default password. In our case, is UHF minus RFID minus device. And then I'm on my reader. You see, in our case, this is RU3560, and it's in my office. And now I address the 1400 reader with a running TagBlower server. And I address the port number 14011. And immediately when I start this, I get the reply, hello world. Now the app is running on the 1400 reader, and you see I still get the heartbeats, I still get the heartbeat information, the system is running. And when I present my tag, I get the information, RFID is coming on port, I get the DIT, and when I'm leaving the tag, it's the same. With the second instance, I will show you that it's possible to have both in the same way. I clear this. And when I start the app again on my reader, then you see after a while, I got my heartbeat on the both sides in the same way, synchronous way. Both are running in the same way. And when I present my tag, I see the information on both sides. And when I'm leaving the tag, I got the same message on both sides. So you see both sides are running, both sides are transmitting the data. And as I said, you can connect different numbers of clients to this TagBlower server. Let's go back to the presentation. And finally here, the advantages of the TagBlower to share with you. So you see, it's an easy data acquisition without programming. You don't need software knowledge. Only the TagBlower app is enough to collect the data. The app runs autonomously. This means it runs also even if the network connection is interrupted, when another connection is still established. So one is at least minimum, and if this is connected, every client else can be connected and disconnected in any way. The data structure is configurable by datagrams. You have seen that we can build up different codings, we can different memory banks, we can set up different addresses and different data to collect. As I said, the instances can be numerous. This means you can have a lot of subscribers on this server to collect the data. We can have up to 4 antennas to capture the data, and with Cry, we can capture up to 32 antennas. with the reader, with the additional Linux on board, with the X500 readers from Kathrein, you can use as a master reader to collect the data from a RU 1400 or for any other reader. So you can design one is a master reader, collecting the information from all the other readers, building up a general datagram, do some statistics, whatever you need, and then you can transmit it to your backend system. And finally, you have seen TagBlower is universal, is simple, and is effective. With a lot of applications, starting from the pure testing during a concept phase when the software is not ready up to this, then you can use already the TagBlower to collect the data to see when which data arrives, in which format, in which coding, and then you can use this and can build up your own software with this. But you can use it also as a part of your solution that the TagBlower will summarize the data from an RU 1400, for example, and send to a master reader. And the good news is, this demo version, this TagBlower is free of charge in the demo version. This means you can test fully with all the things I showed to you, except the runtime. The runtime is limited to 8 hours, but a lot of applications are possible to run within 8 hours, and then you have to reinstall the software. If you want to have 24/7, then it's quite simple. Don't change anything, only change the key handling you have seen in the video with the administration I showed before. You can have a look, how does it work, and then the system is running unlimited. So many thanks for your time, for your attention. I would be happy if you send me a feedback, and see you next time. Goodbye.